Okay, yeah, okay. So this first little bit is just the sort of new lesson plan that they're thinking, or that we're thinking about rather. Although, I mean, I can't say I contributed too much. So send material beforehand for learners to work through before class. So we'll give you guys like some reading or assignments or something. Video, I might do videos occasionally, but that's a lot to ask. Um, so reducing the class time to 1.5 hours, I think that's pretty popular. Bryanston liked that idea. I don't know what you guys think about it. And then the structure of the classes will be like going through the assessments and the reading that you guys were told to do before the lesson. You haven't been told anything yet, but before next lesson. Theory for 35 minutes, and then some kind of interactive or practical session in the last little bit. Here they're thinking like quizzes or like breaking into breakout rooms and discussions and stuff like that. What do you guys think of this? Do you prefer this to what we've been doing up till now? Just a 2-hour lecture? I imagine the answer would be yes. Yeah, awesome. Okay, cool. Okay, good stuff. Yeah, no, 2 hours is a very long time. That's definitely it's a lot to expect from students and from tutors, I'll add. So yeah. Okay, cool. So I mean, anyone else, if you have an opinion on it, then do put it in the chats because it will be communicated to the people. This lesson, I was thinking we would. You guys are way ahead. You guys ahead of you guys. What is happening to my English? You guys are ahead of the other schools. So I was thinking we will just do 1.5 hours today. The other schools are starting on this pattern next week, but yeah, we're finished section 2 already. So yeah, we'll finish at 3ish, I guess. I mean 4ish. Sorry. Cool. All right. So what was the plan again? Okay, so the first thing I wanted to do is just go over the IComparable interface again, because we did it in like the last 10 to 15 minutes of the last lecture, and I guarantee none of you took it in. So we're just going to go over the IComparable interface again. Don't even worry if you don't remember what it was from last week. I'll pretty much cover it totally. And then I'll also give you your first coding assessment or assignment, if you like, and explain to you what I expect you to have done by next week. Okay. So let's just do that, and that'll bring us to the end of section 2, and then you guys will help me decide what we do after this, because I have 2 possible options, and it depends what you guys are feeling more keen for. Okay, so let me just make this full screen so you guys can see more clearly. All right. So the IComparable interface. Remember last week we covered interfaces. We had, an interface for weapons and an interface for enemies. Was a very detailed example. I hope you recall some of it. But the general idea was that an interface is just a class where everything is abstract. Okay? So we can create our own interface like we saw really in depth last week, and that will be your assignment as well. So if you don't know it yet, you probably will by next week. But there is an interface that is built into C#. Okay, so that we don't have to create ourselves. It has a single method that you have to implement. Okay, so if you remember, our interfaces from last week had an attack method that you had to implement. So it was just like void attack, and it had a target, and you had to specify how that particular weapon or enemy attacked. Right? That was our interface. This interface has also just one method. This method it returns an int, okay, and it's called compare to. Compare to. All the IComparable interface is supposed to do is allow you to compare objects. Okay? It allows you to compare different objects with one another. So last week, what we did was we were saying, okay, what if I have this game where we have dragons, all right? And there's dragons that all have a different level. Okay, their level is just an integer, so like level 60, level 70, level 80, whatever. And I want to compare 2 dragons with one another, right? So obviously, if we're comparing two integers, for example, we would say like int x equals 6, int y equals 10, right? And then I could say something like x less than y, right? And that would be a way to compare these two integers, right? In this case, can you guys tell me, do you remember what would this return, this x less than y? What would that return? What would that little command return? Does anyone? True, precisely, yeah, because x is less than y, right? Because x is less than y. Makes sense. But if I want to say, you know, right here, we called our dragons x, we called our first dragon x and our second dragon y, right? It's not as simple if these weren't integers, if x and y aren't integers, but they're dragons. It's not so clear what x less than y would do, right? Well, it would break, quite simply, right? Obviously, it's designed for numbers, okay? So we need a way to actually compare these two dragons, or whatever objects we have created, whether they're rectangles or dragons or polygons or squares, whatever. We want two ways to compare, we want ways to compare the objects that we have, okay? And the IComparable interface, that's what it does, okay? So we did this example very quickly at the end of last lecture, which is why I want to cover it again, where we inherited the IComparable interface into Dragon. Okay, so we created a Dragon class, and we said you're implementing the IComparable interface. Okay, you could do it just like this. Okay, just inherit IComparable, that you might be used to, and this little bit afterwards, the Dragon, that's just saying I'm comparing dragons. Okay. So you could say I just implement IComparable. That would be like I'm comparing general objects. All right. If I want to compare a specific object, I say dragon here. Okay, but you mustn't be too concerned about that. I'm just explaining what these little arrows at the end here mean. So this is just saying I'm implementing the IComparable interface for dragons. Okay, so that's what it's saying. I'm comparing dragons. And all this means is that we have to implement this compare to method, this method here. All right. Now, the dragon example, while it is fun comparing two dragons with to one another, it might make more sense in terms of like rectangles or something, right? So maybe I'm going to put aside the dragons and we're going to go back to something more grounded, like rectangles. Okay. So I hope you guys don't mind. I mean, I can just leave this code here. It's not going to break anything. So I'll just push that all the way to the bottom. And I'm going to create a class rectangle. All right, class rectangle. Hopefully we're pretty familiar with this so far. I think you guys are doing pretty okay on this section, which is nice. So I'm going to do this quickly, all right? So we're implementing the IComparable interface because we're trying to compare rectangles with one another. And I'm comparing rectangles, so I must tell it. Like the type of thing that I'm comparing is rectangles. So we have those things there. All right. Okay. I don't need that much space. I went a little bit extreme. Okay. So, cool, and they'll need a length and a width as usual, so we'll just do that quickly. Public, I'm just going to make them ints this time. That's inheriting, Alex, inheriting. So you remember with classes, that's how you would say rectangle inherits from polygon. With interfaces, we just use a slightly different word. So we'd say rectangle implements IComparable in this case. And we also had, but that's why I think this coding assessments idea will be cool, because you'll have to actually play with that yourself a bit, and so hopefully you'll get the ideas better, you know. Get set. Okay, and get set. Okay, so our rectangles, as usual, have a length and width. I hope I don't have to explain that to you guys. I'm gonna create a constructor. I would ask, I mean, can anyone tell me what's the big rule about constructors? What's the big rule about constructors? Anyone remember? Oh no, we're gonna be here all day. Can't tell, is it people typing slowly or just not answering the question? Nice. Okay. Same name as class. All right, rectangle. Yeah, I've asked you that so many times. I'll stop now. Okay, and this particular constructor is going to take in two things, right? Two integers, one to set the length and the other to set the width, right? Not terrible. And then we just set the length and width. Okay. Currently, this would break. All right, this would not work because we've said we are implementing the IComparable interface. And if you guys remember, if we implement this IComparable interface, in that interface, they define a method that says int compare to. Okay, they don't implement it, so that method doesn't have a body. There's no implementation details. But we need to implement the compare to method. Okay, we need to give the compare to method a body inside rectangle, or it's going to complain. Okay, so how do we give that method a body? We just say public int compare to. That's the name of the method. Right? This method is defined in the IComparable interface. Okay, it doesn't have detail. It's abstract, but it's there. Okay, and in our case, it's comparing rectangles. So our compare to method is going to take in a rectangle, and I mean we can call it whatever we want. I'm going to call it rect, okay, because that's what we've been doing. Okay, and that's just like, that shouldn't be too shocking to you. It's just like our weapons took in, and remember our weapons attack method took in an enemy to attack, right? So it's in the same vein, really. Okay, this one's just taking in a rectangle instead of an enemy. Okay, now this little bit here is it's a little strange. I think you guys will get it, but just tell me if it seems a little weird. Okay, so in order to order something, right? In order to order something, someone's figured out the whiteboard. Good stuff. Okay, in order to order a set of things, we need to know, like if I give you two things and I say order them, what am I asking you to do? I'm asking you to say, you know, which one is first, which one is second, or which one is bigger, which one is smaller, or which one is faster, which one is slower. You know what I mean? If we're ordering things, we need, number one, a way to compare them, but you also need to be able to tell me whether, you know, the one is bigger than the other one, whether it's smaller than the other one, or whether they're the same size. Okay, so we have to find a way to transfer that into code. Okay, so what the compare to method does, all right, what we have to program this compare to method to do is, if what we have, so obviously in this case, our compare to method is working with rectangles, right? So you would give it two rectangles, for example. Rectangle, that's nice actually. I should figure out how to do that. So we would have two rectangles, right? And you need to be able to tell me whether whether the rectangle I have. So let me explain this with the dragons quickly. Okay, so like we would have two rectangles, in this case we have two dragons, right? We have our dragon X and our dragon Y, all right? If I say X, so that's saying dragon X dot compare to Y, all right? There are three possibilities here, right? Either dragon X is the same level as dragon Y. Dragon X could be a lower level than dragon Y, or dragon X could be a higher level than dragon Y. Okay, so there's three possibilities. Okay, so we need a way to encode those 3 possibilities in our compare to method. All right? I hope that makes sense. It's not too difficult, right? And the way we do that, it might seem a little strange, but hopefully you can appreciate why. The way we do that is if x, so if dragon x is a lower level than dragon y, okay? So if dragon x is a lower level than dragon y, then saying x dot compare to y will return -1, or any negative number. It will return a negative integer. Okay, a negative integer. So if it returns a negative integer, that means the thing I have, x, is smaller than the thing I'm comparing to, or like lower in the order, before in the order, if you get me. Okay. Then it would return a negative integer. If they're the same size, okay, then saying x dot compare to y will return 0. All right? So if it returns 0, that means x is the same in the order as y. All right? And lastly, I hope I don't have to tell you, but you probably get it by now. Lastly, if x was larger than y in this case, then it must return 1. Okay? And that's it. So that's all compare to has to do. You're defining some order by saying if you give me any 2 things. So here we gave it dragon x and dragon y. If you give this version of compare to any 2 dragons, it will be able to tell you whether they're the same in the order, whether the one is earlier in the order, or whether the other one is later in the order. Okay. And it's just negative number, 0, or positive number. Okay, positive number means that x, the thing that I'm calling compare to for, is larger. Negative means it's smaller. 0 means it's the same. Okay. Now, cool. So it's, are you guys getting the, can you compare more than 2 objects? Well, Keaton, think about it. So if we have a list of 100 dragons, right? Okay, wait. The short answer to your question is no. Right? The short answer to your question is no. The method takes in 1 object. But what I want you to see is that if you define, remember that it's any 2 examples of that object, right? Any. So you can give compare to. This is great. You guys are like annotating for me. Okay. You can give. Why would you? No. It's a good question, Alex. It's a good question. We haven't actually seen why. It's maybe the course is structured a little bit in a weird order, but I'll explain this now. It's a good question though. So if you have 2 dragons, right, and any 2 dragons, and you tell me, I can define the order of these 2 dragons, right? So I can tell you which dragon is, in this case, a lower level. So which one is easier to fight in our game, for example. Right? So I can define this order for any 2 dragons. Okay. So Keaton, his question came first. If you can define this order for any 2 dragons, then you can define it for all the dragons. If you can, because remember, we can create a list of dragons, right? I could say dragon with 2 square brackets and say list of dragons, right? And that means I can sort this list of dragons in ascending or descending order of level. All right. So all the dragons in the game, if you ask me like what's the 10th strongest dragon in the game, I would just go to the 10th, the 9th place in the list, right? Because we start counting at 0, but the 10th item in the list, and that would be like the 10th strongest dragon. Okay. So we'll see that now. So here we were defining the compare to method, and you see my if statement has level in it. Okay. In our rectangle, we'll use length, width, and maybe even area if you guys want to see that. So, but okay, and then also to Alex's question. Yeah. Well, no, you can sort the arrays, Keaton, but you can sort the array by saying, is this one bigger than this one? Then this one must be before it in the list. Okay, is this one bigger than this one? Then this one must be before it in the list. Is this one smaller than this one? Then this one's in its correct place. So you can sort the whole list, and then you have like a perfectly ordered list of all of the dragons, okay, or rectangles or whatever. Okay, and then Alex's first question, why would you need to compare things? So maybe the dragon example helped there a little bit, Alex, right? Because if we have a bunch of dragons in the game, I might want to find which the weakest dragon is. So you fight that one first, and then you fight the next strongest dragon. Or if I want to find the largest rectangle on the screen, so I don't know, maybe we'll start downloading the largest rectangle first or something. This would be a way to figure out what is the largest rectangle on the screen, or what is the largest rectangle we need to render, is compared to an actual command order thing. Command order thing. Well, so we define the compare to method, right? All inheriting from the IComparable interface, all it guarantees is that if class rectangle inherits from the IComparable interface, then we know it has a compare to method, right? If it implements the IComparable interface, then we know we can compare two rectangles. Okay, because remember, the computer has to be clear on like what can and can't be done, right? So saying we're inheriting the IComparable interface means that we can compare them. All right. As for like sorting and the explanation that I gave to Keaton about this list, we will see how to do that in the next section. There's a section for sorting, and we will see how to do that, like sorting lists of numbers and objects and all of this stuff. But for now, if you can understand, the IComparable interface means we can compare objects, all right? And yeah, and it forces us to implement the compare to method. Okay, but for now, also just understand what the compare to method does. So let's maybe just finish off implementing it for this rectangle. That'll also more concretely answer Maya's question of how do we specify which property to compare. Okay, cool. So we've got our rectangle objects. We're happy with rectangle class, and from it we'll be able to create rectangle objects. Right? So what we have to agree on with our rectangles are basically we just have to agree on an order. All right? So for now, as an initial place, I'm going to say that we're comparing rectangles just on length. Okay? I don't care about the rectangle's width. All right? I'm just saying the rectangle with the smaller length is smaller than the other rectangle. That's how I'm defining the order. Obviously, it's not a particularly clever way, but we will see how to correct that. Okay. So how will I do this? I need to define a method that will return -1 if the length of okay, you guys, I'm going to use the word this. Hopefully you remember what the word this means. Let me just explain it. Cool. So this is how we use the compare to method, right? So we say the one object dot compare to the object we're comparing it to, right? So I'm saying when I say this, I'm referring to this object, right? X, the one we're using to compare to the other one. Okay. So when I say in my rectangle compare to method, I need to return -1 if this rectangle is smaller or before in the order than the other rectangle. Okay, so how will I do that? Okay, so we have an if statement, right? And hopefully you guys know it would use this less than sign. Okay, we just have to decide what goes on the left and what goes on the right. Okay, so if this rectangle is smaller than that, if you like, this the rectangle that comes into the method. Okay, so if you look at our dragons again, this dragon is X, all right, and the dragon that's being passed into the method is Y, all right. So this dragon here that's coming into the method is Y, all right, the thing I'm comparing to. Likewise here, rectangle rect is coming into the method, right? So basically, maybe it'll make more sense after I type it. I would say this, and I can say it literally like that, this dot length, okay, in reality, I don't have to be that specific, okay? It's the same as this. I'm just being explicit, okay? This dot length. So it's saying the rectangle that I'm looking at, all right? Is it smaller than this rectangle that I'm comparing to? And you see this rectangle's name here is rect, right? So it would be rect dot length, okay? So this is saying if the rectangle I'm looking at has a smaller length than the other rectangle, then we're going to return a negative number, okay? The standard thing is to say return -1, all right? You can return any negative number, though. It will work, but we're returning -1, okay? So that's the first bit done. So now I can tell you if one rectangle is smaller than another rectangle in this order I've defined off of length. Okay, I could have used another thing here, right? We can appreciate that I could use something else, all right? But for now, let's just stick with that, okay? But that's not finished now, right? There's still two other possibilities, okay? Still two other possibilities. They could have equal lengths, or this dot length could be greater than rect dot length, right? Hopefully you guys can understand when I say this dot length, I mean this one, right? So that's probably more likely how you would see it inside in the book. Let me just see, actually, there is an example that we would see later where they do this. Okay, no, they do say this, so I'll leave the this there as well, because it is more explicit. It's not necessary, though, right? Okay, so the next possibility is that they're equal. So how do I give another option? Well, I say else. So that's saying if this is not true, else, so in other cases, okay, if else, there else if, so if otherwise, else if, okay, else if, this dot length, how do we ask if two things are equal to each other, guys? What's the operator to ask if two things are equal to each other? Equals equals. So less than, greater than would, so less than will say if the thing on the left is less than the thing on the right, right? Greater than will say if the thing on the left is greater than the thing on the right. And equals equals, that's the one. Equals equals rect dot length. But don't worry, I mean, as long as you understand it when you see it, right? Because remember that you will always see the code in multiple choice, right? So as long as you can understand what this equals equals is doing when you see it, all right? Okay, so if they're equal to one another, we said we want to return 0, right? So we'll return 0. Pretty simple. And in all other cases, so I just say else. I want you guys to understand why I can just say else. Do you get that? Because we've confirmed now if it's less than, then this will happen. If it's equal to, then this will happen. In all other cases, so that means if it's greater than, right? Then we want to return any positive number. You can return any positive number, like 100 if you wanted, or 10 or 9. But the standard, obviously, is to keep it simple and just to say 1. Okay? And so there we go. We've now compared two rectangles off of their lengths. All right. And you see I could have easily just changed length to width, and then we would be comparing them on width. Hypothetically, if you guys remember that area method that we had a while ago, you could also say this dot area, hypothetically, right? We will see that later, so I won't type it up now, because we will see it if we do a little quiz, and then we'll have to go through it in detail again. So let's just leave it with length for now. But are you okay that this method, what this does, is establishes an order? Right? It's establishing an order. So I can take any two rectangles, and this method here will tell me in this, like for this definition of the order, which rectangle is earlier or later in the order, which one is smaller or bigger or whatever. We could compare people, right, on weight. If you remember when we defined that person class with weight and height, we could easily change this to this dot height or this dot weight, or you could even compare hair colors, hypothetically, right? Like which one has fewer characters in the hair color or something. Okay, you can define any arbitrary method, right? So Yeah, that's cool. So that is the compare to interface. We did kind of do it last week, but I think it's probably beneficial to just cover it again. All right, we should probably test this. Okay, I mean, let's do that. Although with the new 1.5 hour thing, we don't really have much time to go super in detail. But we can just test it quickly. It won't take too long. So I'm going to change our dragons to rectangles. Okay, we give them a length and a width. All right, and a length and a width. Yeah, compares two things. Yeah, exactly. And I mean, you can see how it's used. It's like x compared to y. So you just tell it the thing that you want to compare, right? So I'm thinking of x now, and I want to compare it to y, right? So in this case, I'm comparing rectangle x to, okay, we can't compare it to dragon y. We didn't define that. We could have though, but we didn't, all right? Rectangle. Okay, so in this case, I'm comparing rectangle x to rectangle y on their length. Hey, I only care about their length. So what this will say is, look, the length of x is 10, the length of y is 8. So what will this return, guys? Will it return 1, -1, or 0? 1, -1, or 0? What are we expecting? What do you guys vote? You guys think -1? Okay, Keaton says 1, Alex says 1, Amilcar says 1. The answer is in fact 1. Because look, so x is larger than, x's length is 10, y's length is 8. So I would hope this would return 1, assuming we program things correctly. 1. Okay, so there we go. We've now ordered we can order rectangles. You can specify any rectangle length, and I can tell you in our order, our special definition of order, which one is. But you see, this one doesn't care about the width, right? I could make this width 2000. The rectangle y is, in our case, way bigger than x, right? It's just that our specific definition of order doesn't consider that, right? So you do have to be careful. But yeah. So we'll maybe come back to this if we end up doing the quiz. All right, so that's the IComparable interface. Hopefully you guys are feeling pretty okay about that. It's not a huge deal, really. Okay. Cool, so there are now two options. Either we can go through the multiple choice questions together for section 2. They're on page 60. So I set up some slides for the multiple choice questions. Or we can start the next section on application lifecycle management. Which one are you guys feeling more keen for? I'm actually okay for either. You guys are okay. Multiple choice it is. All right. Cool. So let's get started on the multiple choice. I'm skipping the fill in the blank things, okay? Because the books, literally, they take these sentences from somewhere in the book and they just remove a word. Okay, if you're super keen on finding what the answers to those fill in the blank questions are, you can literally just go through the book. Okay, or Google it. Better yet, Google it. Although, actually, some of the answers on the internet to these questions are not too fantastic. Okay. Cool. So, this is the first multiple choice question. Let me move this guy out of the way. This might be a bit of a problem because some of these questions are very long. Okay. First question. You want to restrict access for a method. Oh, you guys have your books open on page 60 and note down the answers, right? Okay. You want to restrict the access for a method to the containing class or to a class that is derived from the containing class. Which access modifier should you use for this method? Public, private, protected, or... Ooh. You guys are saying private. So... let's think about this a little bit. All right, let's think about this a little bit. So we're saying you want to restrict you want to restrict the access for a method to the containing class, right? To the containing class. So if we stop there, we just want to restrict access to the containing class. No other class can access it, right? Then it would be B, right? Then it would be B. If we stopped reading there, restrict access to the containing class. But let's read on. Or to a class that is derived from the containing class. What does that second little bit mean, guys? What does that second little... Oh, come on, you haven't even heard the word internal. You can't be answering D. But also, I saw the whiteboard marker write out B earlier. Or to a class that is derived from the containing class. What does derived mean again? Does anyone know? Can anyone tell me another word for derived? Anyone can tell me another word for derived? Inherited, exactly. So which one... That's not even a possible answer. Okay, but yes, it is protected. Do you guys want to see this again? Or I'll show it to you again, I guess. We can go through one more time what public, private, and protected mean. And I told you to just not care about internal YC. Is that YC? Is that supposed to say that? I think so. Okay, so let's go check that out. Yes. Okay, that took me a while. All right. So should I start up a new example? This should save, I think. There you go. Save, edits, title. Can't I make it the same title? I don't want to open another thing. Version created, update saved. Awesome. Okay, I'm going to hit run code again. That should give me a fresh thing. Yeah. Okay, let's check this out one more time. I'm creating a super simple class. It's going to be very general, and I'm just going to demonstrate it quickly for you. Okay, so I'm going to obviously... no, it's no problem. So obviously in order to demonstrate this, we have to have some form of inheritance. So to remind you, I'll say class my base class. Okay, so I'm defining a base class. All right, class my base class. We're happy with that. I'm going to define a public. I think we could just demonstrate this with a field quite easily. So I'm going to say public string my field. Okay, so no getters or setters or anything. We're keeping it super simple. All right. I'm going to say class my derived class. So this is what derived means, if for those of you who didn't remember. Inherits from my base class. Okay. So we've now got another super simple class. And this class is just going to have a constructor. All right. It's just going to have a constructor. So we'll say public my derived class. Okay, it's going to take in a string to set our field to a value. Oh, to a val. Okay, value is a keyword. Sorry about that. Okay, and then I'm just going to say my field, which is inherited from my base class, right? Equals val. All right? So currently field is public, right? So I'm going to go ahead and create an object of type my derived class. My derived class, I'll call this obj equals new my derived class. And I'll set the field to checking or something, right? Cool. Assuming I didn't make any typing mistakes, that should work. Okay. Oof. Okay, it runs. Oh, we didn't use it, obviously, so let me use it quickly. So it's public, right? Currently my field is public, which means it is break. Okay, we'll do a break just now. Let me finish explaining this first question and then we can. You guys are already taking to this 45-minute schedule, hey? Because now we're like halfway through the lecture. Oh, we need a break, even though it hasn't even been an hour yet. Okay, no problem with that though. It is the new standard. So my base class, my derived class, all right? I'm creating an object of it because my field is currently public. If I say console.writeLine, obj.myField, right? This will print out checking. Because it's public, I have access to it, right? Now, what if I make it private? What happens if I make it private? Okay, so now only my base class is able to access it, right? So if I run this, it gives errors. Lots of errors though, right? If I comment out this line where I access it in main, right? If I comment out that line, you see it still gives errors because my derived class isn't allowed to access my field here because it's private. Okay. But you see, can you guys see, what I want you guys to be able to see here is that there needs to be a middle ground, right? Private makes it only accessible here. Public makes it accessible here, here, and here, right? What if I wanted to only be accessible inside my base class and in the children, if you like, or in the derived classes of my base class? Okay, so I want obviously I want my derived class to be able to set the field, right? But I don't necessarily want main to be able to see it. So the word we use for that is protected. Okay, and now you see it works. But if I try to access it in main, it'll break. Okay. So this is saying it's protected. It's only accessible inside my base class and in anything that inherits from my base class, any derived classes. Right. But it's not accessible in main. Okay. So that's the first question. When we come back from our little break, we'll do the second one. I think let's do like maybe a 6-minute break. So yeah, I'll start again at, I know it's a weird time, but 15:24. It does exist, yes, but I don't want to get into it. If it comes up in questions, I'll like as the answer to questions, I'll cover it with you guys. But to be honest, it's just weird. It's just weird to cover it, or it'll confuse you. Private, protected, public gives you a good scope of the different things that you need to know. Okay. So break, yeah, sure. Until 15:25, yeah. Cool. Let's get started again. Okay. This question doesn't look too bad. Hold on. Can I move this down again? Weird. Oh well. Okay. In a class, you defined a method called render. Okay, render. This method provides functionality to render bitmap files on the screen. Okay, so that next sentence means literally nothing to us, right? Sorry about that. You would like the derived classes to supersede this functionality to support the rendering of additional image formats. Okay. You also want the render method of the derived classes to be executed even if the derived class is cast as the base class. Which keyword? Is it? Oh, right, of course. No, I don't know. I think I just copied the slide from the previous one. Yeah, it's in D is override in my book as well. We can change that as well, but I don't want to show you the answer yet. But I guess that gives away one, right? Okay, so then we say which keyword should you use with the definition of the render method in the base class? Because actually that would be one of the tricky answers, right? You might want to say override. Okay, but ignore D on my screen. Ignore it for now. I'll change it to override right now, but I don't want to show you the answer first. There's still 3 possibilities here. And really there are 2 that you should be sort of focusing in on. Okay, so let me maybe change the wording of the question a little bit, so maybe it'll make more sense to you when you hear it in a way that's closer to how you learned it. So we have a method, right? And here they say you would like the derived classes to supersede this functionality to support. Okay, so we want to be able to override the method. I can use that word because it's not actually one of the possible answers now. We've eliminated it. You want to be able to override the functionality in this method. All right? But you also want the method to have its own implementation. So what they say here is if the class containing the render method is the base class, you still want to have access to the render method. Okay, so what they're saying is the base class must have its own implementation of the render method. Ignore it. Ignore the D here. It's not the correct answer. So just picking between A, B, and C. Okay. Cool. Amilcar says B. Christian says B. Okay, that's all right. Anyone else want to answer? So, okay. Mystery whiteboard person says B. Maya says maybe A. Okay. Cool. So let me show you in code what they're talking about, and then you'll see that actually it's quite simple. Okay. So let's go look at our code. All right, we can actually use this exact same my base class, my derived class kind of idea. The difference is now we're going to add this method called render. Right, we're going to add a method called render. Okay, I'm going to make this just public again to avoid any complications. And I'm going to add a method here called render. All right, public void render. All right, public void render. Let's get over the habit of saying that word. Public void render. There we go. So we've defined this render method, all right, and all it's going to say is, render something. Let's say console.writeLine, render bitmap to screen. Okay, so we've got this method render, okay, and it renders a bitmap image to the screen as it says in the question. Render bitmap image to screen. We don't actually care what that is. In fact, we're not supposed to know, right? It's just the question is they're just trying to frame it in a more difficult way. Okay. Now, having defined that, I want to be able to, in this method, override, supersede this implementation to render different images to this. Okay. So we know that we use the word override for that, right? I'll say public override void render. Okay. And now we'll be going console.writeLine render.svg to screen. .svg image to screen. Okay, so we've now overridden this implementation. If I run this now, it fails, right? Because it says we cannot override the inherited member because it is not marked as virtual or abstract or override. But we don't have to talk about that yet. Okay, so we've experimented with two words here, right? I could either say this is abstract or virtual. Okay, what the question is saying is I want to be able to override this, but I also want it to still have this implementation here. I still want it to be able to render bitmap image to screen, but I also want to be able to override it if I want. Okay, so cool. Let's see that. So if I say virtual currently, let me play with this a bit. So we've got my derived class checking. Okay, that's pretty irrelevant now. Okay, so let's experiment what happens. If I say obj.render currently. Okay, obj.render. Okay. It'll print render.svg image to screen. Okay, it prints render.svg image to screen. So already what we know is we've got this implementation here that can render a bitmap image to the screen, right? We've got an implementation here that renders a .svg image to the screen. Okay. If I say, so this is what happens with virtual. It renders the .svg image to the screen. If I say, let me do this just to show you guys. If I say my base class, maybe should I explain it like this? Oof. Hold on. Yeah, okay, let's go super in depth with this. It's going to take up the rest of the lesson, but we can do it. Okay. Ooh, sorry, what did I do? Okay, right. Okay, look. So we've got my derived class, obj equals new my derived class. Okay, cool. So currently it renders a .svg screen image to the screen. Let's just try out our other option for now. Okay, if I say abstract here, if I say abstract, do you guys know what this will complain about? If you look at just this part of the code that's highlighted currently, are you happy with that? Will that work? Will that work? No. Exactly, it won't work. Do you remember can anyone tell me what it will complain about? What will this little bit complain about here? There must not be a body. Exactly. So if I try to run this now, it'll say my base class render cannot declare a body because it is marked as abstract. Okay. So if I want this to be abstract, then I can't have it render a bitmap image to the screen. Okay. I can't have this render a bitmap image to the screen if this is declared as abstract. Okay. So in order for me to actually declare a body, so what they're saying when they say you also want the render method of the derived classes to be executed even if the derived class is cast as the base class. Okay, I will show you this just to show you what they mean by that little trick. But what you must understand is that there is an implementation. The important part for answering this question in particular is saying, look, the render method exists in the base class. Okay, it must be able to render bitmap files to the screen. Okay, this method provides functionality to render bitmap files on the screen. As soon as you see that this method, the render method, provides functionality to render bitmap files on the screen, you know it can't be abstract, right? Because if it was abstract, then it would immediately break. Okay, we've seen that. If I try to make it abstract, it immediately breaks because it's not allowed to provide functionality if it's abstract. Okay, so we immediately know it's not abstract. Yeah, so and then you can kind of eliminate the rest in that they're not being applied to the method inside the base class. But what is this little tricky thing here? They say you also want the render method of the derived classes to be executed even if the derived class is cast as the base class. Okay, so what are they saying by that? They're saying even if it's such a weird way of wording it, but they say even if the derived class is cast as the base class. Do you guys remember that word is? Right? If I said obj is base class, it would work, right? Like let me show you. Do you guys remember this little thing here? If I say obj, so that's our object of type my derived class, right? If I say obj is my base class, right? So it is of this type. Do you guys remember that if I print this out, it returns true? It prints true. Right? Do you guys recall that? Because obj inherits from my base class, all objects of type my derived class are also my base class. Right? Do you guys remember that? Like all squares are polygons, but also all rectangles are polygons. Right? All doctors are persons, and all... Okay, cool. You guys do remember that. So you remember this word, right? Maybe it shouldn't be too shocking to you, but knowing that, right? So knowing that all my base classes are also my derived classes, it shouldn't be too shocking to you that this is in this case it might give an error because yeah, we have a constructor. But if I just remove that for now and set it to something default, okay, it shouldn't be too surprising to you that I can have a variable of type my base class, and into it I can save my derived class. Okay, because all my derived classes are my base classes. Right? Is that super shocking? I don't know. I mean, it maybe shouldn't be surprising. I would hope that it wasn't based off of how it's been explained. But in a way it makes sense, right? Like a my derived class is a my base class kind of. So you can save it into an object of type my base class. Right? Maybe not too shocking. Think about it like this. When we had dragons and goblins, right? When we passed dragons and goblins into our attack method, we passed them as enemies, right? Whether it was a dragon or a goblin, we didn't care. We passed it as an enemy. And it's a similar thing here. I don't care that it's a my derived class. It inherits from my base class, so I can save it there. So hopefully that's not too shocking to you. And the point that they're making here is, even if this occurs, even if I save it in a my base class, it must still use the overrided version of the method. Okay, and the word virtual will make it do that. All right. It's a mean question. All right, it is a mean question. But yeah, the main thing was deciding between abstract and virtual. All right, based off of what... yeah, hopefully you can see that here. Why it would be virtual, right? It's virtual because it also has an implementation. Right? If it was abstract, we wouldn't be allowed to have that, and so that's not the right answer. Okay, that's the main thing. This extra stuff was just to really cement your understanding of the question more. I'm not sure if it's necessarily beneficial to give you this extra information in terms of passing the test, but maybe it's good. I don't know. It's difficult to say. We will be using this example later as well, I think. Just to... So what would you say abstract does? It defines... I think a nice way to understand it is it defines a foundation. If you don't want to think about it as just defining something abstract. Because just think about how we use the word abstract on a day-to-day basis, right? If I said, oh, it's an abstract idea, what would that mean to you? It means that it doesn't have any concrete implementation, right? It doesn't have any concrete implementation. If I remove this, right, and call this abstract, it's very similar to how you use the word abstract on a daily basis. Okay, in that it's not actually defining a usable method, right? It's just the abstract idea of a render method. It's a renderer. I don't know what it does. I know it returns void. I can tell you the things that a renderer requires, but I'm not getting into the technicalities of what a renderer does. I'm just defining the abstract concept of a render method. You can also think of it as, a foundation or a base. Yeah. Okay, does that make sense? I mean, I think the best way to think about it is just by thinking about it as abstract, as the word abstract, right? Let's see. What is the nice formal definition of abstract? Existing in thought or as an idea, but not having a physical or concrete existence. Okay, so it doesn't have an actual implementation, a body, right? We actually call it a body. That makes it quite nice and easy, right? It's in a way, but it's there to, define an idea, right? We even call this a body, right? We even call this a body. This piece of code here, we call it a body. If we say something is abstract, then it's not allowed to have a body. Right? It doesn't have an embodiment. Okay. And all it's there to do, if you make it abstract, is to say, all right, if it's abstract, all it's there to do is saying everything of type myBaseClass, everything that inherits myBaseClass, has to be able to render something to the screen, but only but I'm only willing to tell you that in an abstract way. MyBaseClass is not taking on the responsibility of defining technically how to render something to the screen. It's just saying, as an abstract idea, you should be able to render something to the screen. Okay, so it's creating an enforcement. And why that's useful, Alex, is to say, if I create something, if I inherit from MyBaseClass, we must get through this. If I inherit from MyBaseClass, then why this is nice is because everything that inherits from MyBaseClass must be able to render something. Okay. By defining this abstract idea here, you're also enforcing it in all of the derived classes. Okay. So you're saying, look, if my derived class was inheriting from my base class with this being abstract, and it didn't define render, then we would get an error. Okay. So it's this nice idea that you can enforce it. All right. Okay, cool. That was virtual though. We maybe went too in depth on that, but it's okay. Cool. You defined a class advanced math, that defines advanced mathematical functionality. All right. You do not want the functionality of this class to be inherited. Ooh, guys, inherited. Oh my gosh, did I not? Okay, this time D was internal. I thought I just copied it again and forgot to change D again. You do not want the functionality of this class to be inherited into derived classes. What keyword should you use to define the advanced math class? Guys, we're talking about inheritance here, right? Not access, not protection level. Okay, we're not talking about the protection level. Okay, we're not talking about the protection level. We're talking about inheritance. Which two words on the screen are relevant to inheritance? Which two possible answers are relative to inheritance? Right? Which ones are referencing inheritance? We know private is D and B. No. So we've now heard C, B, and D. That's not boding well. Keaton Tongue says A. Yes. The silent ones. They're saving you guys. Look, now it's as if you guys all knew A. Okay, wait, but let's think about this a bit, all right? We're talking about the concept of inheritance here, right? We're talking about the concept of inheritance. Private is not talking about inheritance, right? It's talking about access. If I make something private, it's not accessible in any other class, right? Is that what this is saying? It's saying you do not want the functionality of this class to be inherited into derived classes. I mean, I can still inherit something private. I can't set it or get it, but I can inherit it. But also, like, private isn't really getting to, it's not referencing inheritance, right? Abstract, what does abstract means? Abstract does talk about inheritance, right? Abstract does talk about inheritance. Let me think again. Abstract meant that we could only inherit something, right? Abstract meant we could only inherit something. Okay, let's talk about internal. I'll define internal for you, and then maybe you'll see why I don't want to. Internal means that, I guess we can spend the last 13 minutes on this as well. Internal means that it's only accessible inside something called the assembly. But for you guys, just think about that as projects. Okay? So I'll give you a brief example of where this might be used. You might take, for example, if we're creating an application, okay, like YouTube. You know YouTube has a mobile version and it has a web version, right? If we will have a mobile application and a web application. They're a part of the same app though, right? But they are like totally separate assemblies, we might call them. Okay? Internal means that you can only be accessible in one of the assemblies. So like if it's internal to the mobile application, then only the mobile app would be able to access it. The reason we haven't discussed it is because it's very difficult to set up an example where you would see this, right? Because we have to create multiple assemblies. But I can send you a video as your extra reading, explaining what internal does, if you like. But you'll see it's like video 144 in like a series, or something. It'll be a huge number, maybe even 500 or something. You would learn that very late into a C# course. Anyway, so sealed, abstract, private, internal. It's not internal and it's not private because those aren't even talking about inheritance. Okay, so we should immediately be able to eliminate these because they're not about inheritance. Okay. Sealed and abstract. Abstract means I'm only allowed to inherit it. Sealed means I'm not allowed to inherit it. So it's A. Okay, it's A. I don't know, I can show you that little diagram if you don't remember what I mean by that. But I think we covered it pretty in depth on that day. So I don't want to spend too much time on it, but I can just show you the diagram quickly, talk you through it a bit, and then maybe we can do even one more question, and then quickly finish off this multiple choice stuff next week. I think it was this set of slides, correction and interfaces. No, it wasn't. Oh no, Zoom. Go away, go away. Slides 5 maybe? No, it'll be slides 4 here. Ugh. I really should name these things better here. Okay, cool. It is this one. We can go over to the slide that it is. It's this one. All right. So let's quickly just revise this concept. Okay, so there's these two words, abstract and sealed. They're talking about inheritance. Okay, if I make something abstract, so I make my base class abstract, okay, that means I am not allowed to directly create an object of my base class. Okay, that's what abstract means when we apply it to classes. Okay, you're not allowed to instantiate it in an object. Thinking about that explanation of the word abstract we had earlier, think about it in terms of the person class, right? When you actually create an object, you had to give a person a weight, a height, and a hair color, right? You had to give them a body. But abstract things aren't allowed to have bodies. So if you make a class, if you made our person class abstract, you wouldn't be allowed to create an object of type person. Okay? You would have to inherit it into something else. Right? That's what abstract means. Sealed means that you are not allowed to inherit from it. So in this case, if we made polygon, our polygon class sealed, then rectangle would not be allowed to inherit from polygon. So all of this bottom thing would be impossible. Okay? So if you want something not to be inherited from, okay, then you can make it sealed. All right. So the answer is sealed. Cool. Slightly difficult, but if you know what sealed and abstract mean, then that maybe is fine. And again, a lot of these questions become easier after you've seen them for the first time. Like most questions, actually. You need to provide query functionality to several of your classes. Each class's algorithm for the query will likely be different. Oof, this one might get a lot of you guys. I don't know. It is a little mean, this one. Also, not all the classes have a... Wait, does it say and in the book, or is that me? Okay, in. Not all the classes have an is-a relationship with each other. How should you support this functionality? Okay, so there's a few possible answers here. They say, add the query functionality to a base class with the public access modifier. All right, so we should probably discuss this question more in depth. Have all the classes inherit from an abstract base class and override the base class method to provide their own query functionality. Have all the classes inherit from a base class that provides the query functionality. Create a common interface that is implemented by all the classes. Now, it might seem intimidating because of how abstract the question is, if you like. But it isn't. If you know the answer... Alex says D. I'm proud of you, Alex. I'm proud of you. The answer is D. Okay, but I think we probably should... It is. It's D. You see, it's highlighted in green there. Slides don't lie. Also not... But let's maybe discuss this more in depth until the end of the lesson. All right, because it's definitely worthwhile. No, it is tough. That was impressive. Because if people guess, they guess B. That's always the safe option. You never guess D. So if you pick D, you know the answer. You must. Okay, but let's discuss this more in depth. I am not sure if we want to program these up because it might take very long. Big smart, yeah. Okay, so let's go through the options in an abstract way as they do. Okay, you need to provide query functionality to several of your classes. So what are we saying here? They're saying several of our classes need to implement the exact same method. Okay, several, or not the exact same, but it needs to be a similar method. Okay, several of our different classes need to implement a method. Okay, let's just say a method for now. Each class's algorithm for the query will likely be different. Okay, so let's rephrase this as dragons. Okay, you have several dragons. They all need to be able to attack, but they all attack in slightly different ways, right? Like some breathe fire, some breathe ice, some breathe, I don't know, blood or dirt or something. Okay, they all breathe fire in slightly different ways, or breathe... or attack in slightly different ways. Okay, Also, not all the classes have an is-a relationship with each other. Okay, turns out we don't only have dragons anymore. Okay, we actually have a bunch of different types of things. Okay, we don't just have dragons, we also have goblins, robots, and ninjas. Okay, and they all have to attack in a slightly different way, but they are all attacking. Okay, how should we support this functionality? Right, let's go through the possible answers. Add the attack functionality to a base class with a public access modifier. Is that correct? No, because if I add attack functionality to my base class, then dragons, goblins, robots, and ninjas will all attack in the same way. So A is definitely not it. B, have all classes inherit from an abstract base class and override the base class method to provide their own attack functionality. This is very close to being a valid answer. Very close. It's very subtle why it's not. Unfortunately, I don't think we have time to say. Let me see. What is the time? 15:56. It has to do with the override functionality not doing what we think. Not doing. Wait, how do I get the chat back? That's annoying. More chat. There you go. It has to do with override not actually replacing the previous functionality, but only sort of replacing it in this context. Okay, we'll see that in more detail next time. I'll explain more in detail why it's not B. Okay, have all the classes inherit from a base class that provides the query functionality. Okay, so we obviously don't want to provide the query functionality in the base class because all of them are going to be different. Okay, it has to do with this is a relationship. Okay, as well, because if I say, let's explain it like that as well. If I say no, okay, I will go more in depth next time. We don't have the time. But it is D, create a common interface. Part of the reason why you should know that it is create a common interface is because that is the correct way of doing it. Okay. They also do say how should, because I do think B, you could possibly do this with B without having any problems. Okay. But in general, when you heard me describe that example at the beginning, right? We had a lot of different enemies. They were all attacking in slightly different ways, right? And it's the same if I word it like this. We have a lot of different devices. They're all accessing our database in slightly different ways. How do we implement that? You guys, when you hear that kind of phrasing, you should always be thinking, okay, interfaces, all right? Where there's a lot of things that require a specific kind of functionality, but it's slightly different for all of them. We'll always use an interface, okay? Particularly if this is a relationship is true, but we'll get into that more at some other point. Okay, yeah. So we will, I think, do question 4 again next week. But wait, in the last little bit of time, I need to show you your assessment or assignment or whatever, your thing to do on your own time. Okay, so I'm going over to this. All right. Last week, I'll share it with you again this week, but last week I shared this code wall with you, this very detailed interface example. Okay. I'm going to actually remove the... actually, it's fine. We can keep it. Hopefully you guys remember how that works. I don't... It might break it for a lot of you. So I'm going to remove that and just... Okay. Maybe I should share Bryanston's with you instead. Okay, it doesn't matter. Point is, we have this very detailed interface example. You guys remember we added goblins and dragons and swords and bows. Okay. What I want you guys to do on your own for next week is add either your own weapon or your own enemy. Okay, so I'm going to comment at the bottom of the code here. Add your own enemy or weapon. Okay. And that's it. You just have to create your own class that makes your own enemy or weapon. I'll tell you now, weapon is slightly more difficult. Okay, weapon is maybe very slightly. It's not a huge difference. You guys remember. Compulsory. I think it's better if you do it. Okay, it's definitely better if you do it. And also, this is a pretty fun assignment. It won't take you too long either. Let's think about this quickly. Right, so what I have to show you is how to actually get this code for yourself. Okay, so I'll send you the link. All right. When you open it, it will look something like this. All right, probably without show input. All right, it'll look something like this. Okay. Hopefully you remember what this is doing, but let's actually keep it simple and say weapon equals new bow. Okay, weapon equals new bow. Enemy equals new dragon. Okay, I'm going to remove these guys as well. And we're just going to say weapon.attack enemy. Okay, something like that. All right, so when you open the code, it'll look something like this. Okay, I'll have to copy paste that again. All right, it'll look something like this, and all you have to do is click fork it. Right, you have to click fork it, and you'll give it your own title. So you can call it make my own enemy or something. Make my own enemy, and then click OK. Okay, and you can leave it on everyone can see, only me can edit. And then you'll have your own version of the code that you can work on yourself. All right, so you click fork it, you give it a name, you hit OK, and then you'll have, you see it gives you a link, and this will be to your own version of the code. All right, and when you use this, you'll have to click edit mode in the bottom here. Okay, you have to hit edit mode so that it allows you to edit the code. All right. Not too complicated, and you can just ignore the show input thing. It's not relevant. All right. Cool. So that's it. You just have to do that and may add your own enemy to the game where the comment is. I'll have to add the comments again, I think. Yeah, I do. Okay, so okay, cool. Hopefully you guys won't have too much trouble with that. It's not particularly difficult, and yeah. Yeah, no problem. Save edits. I want to keep it the same name. Cheers. Gonna take some getting used to ending this early. Very detailed interface example. Okay. Run it. Cool, so that works. Let me also just add that comment at the bottom. Make your own weapon or enemy here. Okay. Cool. There you go. It'll now be doable. I'll send you the link to this code, and you guys can do it there. Awesome. Yeah. Cheers, guys. Cheers. Yeah, you too. Cool. Stop sharing. Finish recording.